When we simplify a rational function, we sometimes need to be specific about what happens to the domain. For example, suppose we have this rational function. And in particular, I want you to be aware of its domain. Its domain is all of the values of x, such that this denominator is not 0. But now suppose we simplify this. We'll want to factor the numerator and denominator. The numerator has no common factors, so we want to split up the middle term as two numbers whose sum is -1 and whose product is 2 times -6 is -12. A little bit of computation shows us that we want -4 and +3. Greatest common factor in this row is 2x. In this row is 3. What's left here is x. What's left here is -2. So my factors will be 2x plus 3 times x minus 2. As for the denominator, we have x squared minus 6x plus 8. Again, we see no common factors, so we want to split up the middle term. This time we'll need two numbers whose sum is -6 and whose product is 1 times +8. Again, a little bit of calculation will show us that we want -2 and -4. Greatest common factor in this row is x. In this row, -4. What's left here is x, which works. What's left here is -2, which works. My factors will be x minus 4 times x minus 2. So my f of x will be 2x plus 3 times x minus 2 over x minus 4 times x minus 2. I see that x minus 2 is a common factor, and I'm left with 2x plus 3 over x minus 4. Oh, but that had an effect on the domain, didn't it? Right, the implicit domain of this expression is just all of the x where x is not 4, right, where x minus 4 is not 0. But if we solve the equation related to this original restriction, well, we've already factored this polynomial. We see that actually the domain of f should prohibit 4, yes, but it should also prohibit 2. In general, what do we need when we've simplified a rational function? When we've simplified a rational function, we need to add a restriction that the factors that we've canceled can't be 0. So let me show you another one of these, and then I'll have you try one. Suppose we want to simplify the function g of x. Well, we'll factor the numerator, splitting up the middle term as two numbers whose sum is -2 and whose product is -8. I think -4 and +2 will do that for us. Factor out a common x here, a common -4 here. What's left here is an x. That works. What's left here is a +2. That works. So my factors will be x minus 4 times x plus 2. In the denominator, I'll have splitting up the middle term as two numbers whose sum is +4. I think that 2 and 2 will do that for me. Factor out a common x here, a 2 here. What's left here is an x. That works. What's left here is a 2. That works. Oh, this is going to be x plus 2 times x plus 2. What will my g of x be? X minus 4 times x plus 2 over x plus 2 times x plus 2. Cancel those out, and we get x minus 4 over x plus 2. But this factor that we canceled is not allowed to be 0, so x can't be negative 2. Oh, in this case, x still can't be negative 2. We still have a factor of x plus 2 in the denominator. So, in this example, we could leave this out, but we can leave it in as well. I'm going to give you one of these to try. Simplify h of x equals 2x squared minus 4x over x squared minus 7x plus 10. Pause the video and try this now. Alright, factoring the numerator and denominator. 2x squared minus 4x. I see a common factor of 2x. And what remains is x minus 2. Factoring the denominator, I see no common factors. I need to split up the middle term. I need two numbers whose sum is negative 7 and whose product is 1 times positive 10 is positive 10. I think negative 2 and negative 5 will do that for me. Greatest common factor here is x, here negative 2. What remains here is an x, here a negative 5. And both of those work. X minus 2 times x minus 5. So my function, h of x, is 2x times x minus 2 over x minus 2 times x minus 5. Canceling the common factor x minus 2, what I'm left with is 2x over x minus 5. But I need a restriction that this factor I canceled cannot be 0.